Lesson 6 on sequences and series. Please subscribe, like, share, and comment. In this lesson, we are talking about geometric sequences. Let's begin by the definition. A geometric sequence is a sequence in which each new term is obtained by multiplying the previous term by a constant value. You must take note that the first term is excluded. Now, that constant value is called the common ratio. The common ratio, and we denote it by the letter R. Suppose we have a sequence T1, T2, T3, T4, going on and on. The common ratio R is given by R is equal to T2 divided by T1 is the same thing as saying T3 divided by T2 is equal to all the terms up to Tn divided by Tn minus 1. Let's consider the number pattern 2, 6, 18, 54, and so on. The common ratio R is equal to, so this is an example that we are working on. The common ratio is given by T2 over T1. We can just use that one. We can use T3 over T2. We'll get the same thing. So we're saying now R is equal to 6 divided by 2. So that means R is equal to 3. T1 is equal to 2. T2 is equal to 2 times 3. So we are multiplying that by the common ratio. You remember that constant difference that we say we are multiplying each and every term by that. Then we have T3 is equal to 2 times 3. So this 2 times 3 is T2. So we multiply that by 3. And we are going to get 2 times 3 squared. And T4 is equal to 2 times 3 in that same manner, times 3, thus giving us 2 times 3 to the power of 3. And then we can do that for T5. T5 is equal to 2 times 3 times 3 times 3 times 3, and that gives us 2 times 3 to the power of 4. And you realize from this, you are having 2 times 3 to the power n minus 1. N is 5. Okay, so we're going to say 2 times the common ratio to the power of n minus 1. And in this same manner, on this part, we can say T4 is equal to 2 times 3 to the power n minus 1, because n was 4, so we're saying 4 minus 1, we get 3. The same thing applies to T3. And in that regard, we can easily find any term. For example, we can find T10. We can say T10 is equal to 2 times 3 to the power 9, because we are saying 2, the first term, times the common ratio to the power n minus 1. N is 10, all right? And we can still further do another example on that. We can look for T1000 using that same principle. So we'll be having T1000, the 1000th term is equal to the first term times the common ratio, which is 3, to the power n, which is 1000 minus 1, and that will be 999. And according to this example, we can easily deduce the general term of a geometric sequence. So we can say now the general term in this case is Tn in our example, all right, is equal to the first term multiplied by the common ratio to the power n minus 1. So these are multiplying each other. And the general term for all the geometric sequences is given by Tn is equal to A, the first term, you remember 2 is the first term, multiplied by the common ratio, which is 3r to the power n minus 1.